Hello everyone, welcome back to another video on my YouTube channel. Today we are discussing another problem from the 975 list of problems, and this problem is called reorder list. In this we are given an input linked list L0 to Ln, and we have to order the linked list in the form L0, Ln, L2, Ln minus 1 and so on. That means what we need to do essentially is that take the first node from the list, that should be as is, then take the last node, then take the second node, then take the second last node, then take the third node until the list gets over. So it is also given that we cannot modify the values in the list nodes, only the nodes themselves may be changed. That means we need to change the pointers only. We don't have direct access to the nodes. That means we can't just change 2's value to 5 and 5's value to 2. We need to move this complete node here itself. So let's see how we'll approach this problem. Now the first thing I notice is that one list is starting from the beginning, that is 1, 2, 3, and the second list is starting from the end, that is 5, 4, and so on if there are some other nodes. So what we need to do is separate this into two lists. For example, this will be 1, 2, 3, and this will be 4, 5. So say that we are able to separate this. So this will be 1, 2, 3, and null, and this will be 4 and 5 and null. Now, once we have separated this into two equal lists, or in this case, it can't be equal as there are 5 nodes. So one will have more than the other, but almost equal. So in that case, once we have these two lists, what we'll do is we'll reverse this second list. So once I reverse this, this will become 5, 4, and null. Okay. So this is my first list. This is my second list. And once I reverse it, so this will become 5, 4, and null. Now, once I have these two lists, I'll simply merge them to get the resultant list. So this will give us our answer. Now, separating this into two lists will require finding the middle node. We'll have to somehow find the middle node here. So to find the middle node, we can just use the slow pointer and fast pointer technique. So we'll take two pointers, one is slow and one is fast. And fast will move 2 steps at a time and slow will move 1 step at a time. And when the fast pointer reaches null, slow pointer will reach the middle node. So that means we are able to find the middle node, and we can break it off either from here or from here to create two separate lists. Once we have done that, to reverse the second list, we can simply use the reverse problem we discussed around 1 or 2 videos back. So I will leave a link for that video at the top right or in the description, and you can watch that video to understand how we reverse a linked list. Now, once we have reversed this linked list and we have this first linked list, we'll just merge those one by one. So we'll take two pointers, one here and one here. Take a node from the first list, increment this pointer, take a node from the second list, increment this pointer, and so on until we reach end of both lists. And once we have this resultant list, we'll just return the answer. Great. Now, what would be the time and space complexity for this? So we are iterating both lists once, and splitting it into two will O of n, reversing will also be O of n, and merging will also be O of n. So overall time complexity will be O of n. And what about the space complexity? We are not using an extra space. We'll just split the input list only into two lists. And during merging also, we'll create only one list. And the reversal also will not take any extra space. We'll do it in memory using the same list. So space complexity will be O of 1. Now let's see how we'll code this problem. Now we are given a function called reorder list, and list node pointer called head is passed to it. Now let's start by coding this out. We are this function is also returning void type. That means we need to just modify head in it, and the question checker will just use the head pointer to find if the list is modified correctly or not. Now let's start by building the three functionalities that we discussed. First was finding the middle node. So let's create a function called find middle for that. The second thing was reversing the linked list. So we'll create a function called reverse LL for that. And the third thing we discussed was merging the two linked lists. So for that, we'll create a new function called merge to LL. Let's start with finding the middle node. So this will return a list node pointer, and we'll take an input of type list node star. And to find the middle node, we'll use the slow and fast pointer technique, where fast pointer will move 2 steps at a time and slow pointer will move 1 step at a time. So let's clear those real quick and start with the loop. So while fast is not equal to null pointer and fast's next is not equal to null pointer, I'll do slow equals to slow's next and fast equals to fast next. And at the end, slow will reach the middle node and I'll just return the slow pointer. Now another function we'll describe for reversing the linked list. This I've already discussed in the past videos, so I'll leave a link for that. So let's just quickly go over it. So I'll need a previous node of which will be initially null pointer, and I'll iterate the list. So while head is not equal to null pointer, head will become equal to next node, which I'll find at the beginning. So nxt, and nxt I'll declare quickly nxt will be equal to heads next, and heads next I'll change to previous, and previous I'll change to head. And at the end, the previous will contain the new head. So I'll just return that. And for merging two linked lists, I'll create a function called merge to LL. It will have two inputs, L1 and L2. So let's write those. Now to create a new list, I'll take a dummy node. So dummy is equals to new list node and initially give it a value -1. And I can solve this question without using this dummy node as well, but this just makes it easier to find which node will be first. So using it just for that case, you can write the complete code as well, right? Taking the L1 node first, then L2, then N1, then N2, and so on. So list node star current will be equal to dummy, and now I'll iterate both the lists until any of them becomes null, and keep adding nodes from L1 and L2 consecutively into this dummy list. So first I want the node from the first list, which will be 1, 2, 3 in this example, and the second list will be 4, 5. So let's take cur next equals to L1, and I'll also change L1 to L1's next and cur to cur next. And similarly, I'll do the same for the second list. So let me just copy paste, replace L1 with L2, and that should be it. Now if any of the lists remain with nodes, I'll just add it to the current list. So if L1 equals to not equal to null pointer, cur next equal to L1, and same for L2. Now actually I don't need this for L2 because we know that if odd number of nodes are there in the list, then L1 will have one greater node than L2. But I'm writing this just for the sake of it to make the function more generic. But this second if statement is not required. And at the end, just return dummy nodes next. Because initially we took it as -1 and I want to return the next node from it, which will be 1 in this example. Now let's write the main function using these three functions we just created. So first of all, if head next, okay, we are given that the number of nodes is in the range 1 to 5 raised to 5 into 10 raised to power 5. So let's write the base case first. So that means there is one node or two nodes. That means if head next equal to null pointer and head next equal to null pointer, in that case we'll return directly because that won't require any modification. And then go on, find the middle node. Once we have the middle node, I want to reverse the list after the middle node. So let's create the second list first. So L2 will be mids next, and mid next I'll change to null pointer so that the first list, which was L1 or head, becomes separated. So 3's next will become null and 4 5 will become the second list now. So mid next will be null pointer, and now I want to reverse the second list. So reverse LL of L2. Now once the second list is reversed, what I want to do is merge the two linked lists, which will be head and L2 now. So this should give me the final result and it should store it in head. Let's try running it. I'm getting a wrong answer. Something I'm doing wrong. Let's check it out. Okay, so in the reverse linked list, I'm supposed to return the new head. So L2 will be equals to reverse LL of L2. So this was missing. Now it should be fixed. In merge also we are returning a list node, but we don't need that because we are just we don't need to return that. So head will automatically be used to check the result. That is not required. I think that should fix it. Now let's try running this. So our sample test case has worked. Now let's try submitting it. See, if we even use head equals to merge to LL, it will still be accepted. And let's try submit. Because as you can see, our O of N solution worked. Do like, share and subscribe to this video and stay tuned for the next video. Till then, happy coding.